Good afternoon, everyone. Welcome back. I know it's a Sunday, so you must be feeling, but see, your exams are very near, and so we would like to revise everything very well. And I'm sure more and more students will join. Yes, yes, Anushka, Aisha, a very good afternoon to all of you. आ गया? हाँ. Okay, so let us start with this topic of revision of differentiation and integration. Okay, so, and as you know, let's first talk about the weightage. So 4 to 5 questions maximum you'll get from this topic. And the important thing is now the trigonometric applications are have been removed, so you don't have to worry about those sine, cos, tan. Now let us dive into what the topic is telling us about. Now, differentiation is a powerful tool, okay, that allows us to understand and quantify change. Okay, this change, whenever we see change and we want to know how much the change is, what is the effect. So we will talk about the effect later, but first we will know how much is the change. And for that, we must understand what type of change we are trying to study, and we want to quantify. That is, we want to put it in numbers in various real world scenarios. The applications are widespread, influencing fields ranging from science, engineering, economics, and medicine. So, as you can see, it is also applicable to us, the chartered accountancy course and finance. As you know now, like business analysis, analyst, you keep hearing your elder brothers and sisters or their friends talking about he's got a job as an analyst. Okay, so when they are doing that, of course, they are learning all the computer languages, Python, it's those are there, but the understanding, the base information is studying integration, differentiation, probability, you know, standard deviations, all those together, you, they help you become a good analyst. So this is a very good chapter in the long run.
Thank you, madam. Thank you so much for your brief introduction about the application side of the uh, entire portion of this, like a quantitative aptitude. Now, coming to the business aspects, actually, or economic aspects of the differentiation, it is majorly used in the field of economics. Also, our subject is I mean, like. We are in the like applied to the economics and the finance aspects only actually. Like that actually, especially in the when we are talking about the economics means it's a marginal utility functions like marginality. When utility function is given, based on that actually, how to calculate when there is a 1 unit change in the commodity, what is the utility function would be changed. Like that, when there is a commodity given, the like what is the marginal cost, total cost is given. What is the marginal cost would be changes. When total revenue is given, what is the marginal revenue would be changed. Here, rate of change refers to the by using the differentiation methods only. Actually, when it is the rate, when we know the rate of change also be that function, then using that, how much total revenue would be also the reverse is the total revenue how would be finding, and total cost how would be finding using the application of integration also. With these words, actually, I want to just to take the lead of the that C. Rashmi Madam. She has a huge, vast experience in the field of quantitative aptitude also. And my request is the students don't fear on this topic also. It's a very interesting and 4 questions would be coming from this chapter. Actually, very simple, and there is need to fear on this topic. Differentiation 2 questions, integrations 2 questions, maximum of 5 questions may be chances set. I mean, all are simple and applications. If you thoroughly read all the aspects of like formulas what are given in this study material and go through, and we should you can easily attempt in the all the information. Over to Rashmi madam.
Thank you, sir. Thank you for your take on this subject, and you very rightly talked about the practical application in terms of costing. So where we are finding the marginal cost and revenues. Very nice example, sir. Thank you so much. So trying to understand this. So suppose you and your friend are trying to go to a movie. So there can be two aspects. You want to see a movie which is very popular, okay? And you want to see whether a movie that is highly rated, so that it is made very well. It has a critical appeal. So how do you do that? What you do is you start seeing how many people have viewed it. So, and then you start looking at how many people saw it last week, how many people saw it this week. So, when you're doing that, you find the derivative of the user rating, and there you will be able to see that, okay, this movie is picking up. Okay, this movie is more of word of mouth. So, people are going more to watch that movie. And so, I mean, simple things like we do it actually, but we don't say we are using differentiation and integration. But yes, all the channels who are talking about movie rating, TRP rating, and all those things, they use this kind of thing. Second example is towns population. Okay, so towns population, there is going to be an increase or decrease depending on whether there are more births or deaths. So there also these concepts are used. Now, importance, Sir has already told us about this, so let me skip that. So, what is it? If you have a function that describes a relationship between two variables, differentiation helps us to understand how a function's output changes with respect to the input. So, you have an input, you have a function, and you have an output. So, changes in input, how they are affecting changes in output. Okay, so that we are able to understand. To express the rate of change, we introduce a concept of derivative. So when we are talking of derivative, we are talking of rate of change. Okay, so what it gives us, a very small change in the input, how it is going to affect the output, whether you have proportional change, whether you have inverse change, and what is the quantum of change, that all you can understand using your differentiation or derivative. The theory question you can have is on the first principle. So what here is, we say is, let y be fx, that y be a function of x. And then we say there is a small change in x. Okay, so we write it with delta x. Okay, so this triangle is called as delta. So delta x. So if we can call it also as h. So if h, that is delta x, is a small increment in x, what will be the corresponding? What will be the corresponding change in y? This is given by this. Limit h tending to 0, f of x plus h minus fx upon h. Okay. And in terms of delta x, you can write it as this. So this is known as the first principle. This is called as f dash x. Okay. So it is called as f dash x. Also represent as d by dx of fx. Okay. Anybody has any question, you can put it quickly in the chat box so that we don't waste time in unmuting, muting you all, so that as soon as I see the question also, I can answer it. Okay. So f dash x or dy by dx, is known as the differentiation. This process of differentiation is called as the first principle ab initio. Okay. Yes, Manisha, good afternoon. Shubhi, I think you had a question. You could put it here. Okay, so we have this principle. Then these are the formulae. As I was telling you, you must know these simple formulae for you to be able to attempt questions on differentiation. And similarly, you have for integration. Okay, I'll just see this questions that you have put in. Okay. Yes, should we put the question? Have you put it in the chat box? Let me check. Now, what are the formula? D by dx of x raised to n is n x raised to n minus 1. So, if I have something like x raised to 5, I will use this formula. Then, if I have exponential d by df of ex is equal to e raised to x. Okay, so you must remember this. Sometimes what happens, we by mistake use the formula for a raised to x. So this is exponential. So exponential function, derivative and integration of the exponential function e raised to x is always e raised to x. Yes, Fatima, I'm receiving your queries. Yes, Abhinandan. Abhinandan, you could, just cancel and then rejoin the Zoom app. Okay. Shubh, you have some questions? Have we put it here? Then d by dx of a constant is always 0. So suppose I have d by dx of 7. Okay, the number 7. Then it will be 0. Now here, the difference between here and here. Okay, you can see the formula. See, I'm always emphasizing for differentiation integration. If you're clear about the formula, you can get the answers very quickly. So you must know which formula to use when. See, here what is happening? You have e raised to x. And what is here? E raised to ax. Okay, so this is e raised to x and this will be something like e raised to 4x. Okay, so if you have this number here, you're going to use this. You may even have e raised to 3x by 2. Okay, then also this is a number. So what is it saying? A e raised to ax. Okay, so in this case, it will be 4 e raised to 4x. Okay, again, it will be e raised to 4x. Then d by dx of log x is 1 upon x. This is also very conveniently used, especially in integration, when we are doing integration by parts. So this is an important formula there also. And then d by dx of c fx is equal to this. You don't have to worry. Just means that if you have d by dx of 9x, it means it is equal to 9 d by dx of x. Okay. What this means is if you have a number here like 9x, then you will have 9 you can take out of the derivative and you will only find the derivative of the algebraic function here. So if this is my function fx, how will I write it as f dash x? The derivative will be f dash x. X raised to n derivative will be n x raised to n minus 1. E raised to x will be a e raised to ax. Log x will be 1 upon x. Then a raised to x will be a raised to x log a to the base e. Okay. Now we will be doing all these questions here. Now
Madam,
there are certain rules. Yes.
madam,
Yes, sir.
let's go to the basic class of for differentiation. That is like sum, difference function, product of functions, and quotient of functions. Then you go to the examples. That would be best.
These rules, na, sir?
Yeah, yeah, yeah.
Yeah, I'm explaining them one by one.
Yeah.
Yes, sir. So this we have done, that if you have any scalar multiple of a function, you will take it outside. So if my function is, as I told, okay, if we have 9x square, then if I want to find d by dx of 9x square, what this means is this 9 will be my c and this x square will be my fx. Okay. This means, see here, d by dx of hx is c d by dx of fx. Means what? I will take the constant out, 9 d by dx of x square. Okay. And then we will do proceed further. So this is one rule. Second rule is for addition and subtraction. What happens if I have addition of two functions? How do I find the derivative? So I have 5x square plus 4x. Suppose I have this. Then if I want to find d by dx of this function, so what do I do now? What does this means is that if my hx, if my function is an addition or subtraction of two or more functions, then how do I find it? D by dx of hx will be d by dx of fx plus d by dx of gx. So this is my first function and this is my second function. Okay. Then what will be the derivative of this hx? This will be derivative of first function plus or minus, depending on what sign here it is, derivative of second function. Okay. So what happens is, now if I have a function which is addition of two functions, then and if I want to find the derivative of such a function, it will be derivative of the first function plus derivative of the second function. And same thing applies for the subtraction sign also. And we will be doing sums on this, but this is only talking about the rules that are there. Okay. What about if I have products? Okay, now you have this. This is an important um, rule. So if my hx, if my function is a function of multiplication of two functions, then the derivative will be equal to first function into derivative of second function plus second function into derivative of first function. Okay, so if this is my first function and this is my second function, then first function into derivative of second function plus second function into derivative of first function. See, those of you who are comfortable talking about fx, gx and all, you can use this formula. Okay. This is only what? The same formula in words. Okay. So if you want to remember, so what I have, if my function is a multiplication of two functions, then how will I find it? Like you're talking to yourself, you can do that. And then you can say second function into derivative of first plus first function into derivative of second. So I don't have to worry, because sometimes if you have studied this in your class 12, the symbols may be different. They may be using xy or some other, and here we are using fg. So if you don't want, if you're getting confused, all you need to do is just put it in words. Okay. So what have we done? First, we've talked about if the function is multiplication of a scalar with a function. This is the rule that you have to apply. Second is if the given function is an addition or subtraction of two or more functions, this rule will apply. And third is if it is the multiplication of two functions, then this the derivative will apply is first function into derivative of second plus second function into derivative of first. Okay, you can use it very easily. And then the next one is division. Okay, so now what is happening? If I have a function which contains the first function divided by the second function. Okay, so it is a division of two functions. So I call this what? I call this the first function. What do I call this? I call this the second function. Okay, so d by dx of hx is, in the denominator, it is gx the whole square Then in the numerator, it is gx d by dx of fx minus fx d by dx of gx. Okay. And how do I always remember? Since my college time, I say that h dash of x, the derivative of a function which is the division of two functions, is given by, I will write down here, second function whole square in the denominator. I will write the denominator first so that I don't forget it. Then here, second function into derivative of first function minus. Okay, so this is a very important thing, because in the earlier we were talking about plus, here it is minus sign. Minus first function into derivative of second function. Okay, so when the function is a division of two functions, then its derivative is given by, in the denominator, second function whole square. In the numerator, you will have second function into derivative of first minus first function into derivative of second. So if you've understood, just put it in the chat box. If you've understood the rules till here. Yes, Fatima, good afternoon. Abhinandan. Deepak, which formula you want me to repeat? Just put that. Abhinandan, you will have to rejoin. Doesn't matter. Sometimes your connection is low, so you can rejoin. Okay. So you can just ask, and then the host will rejoin you. Yes, Devendra has understood. Natasha has understood. Yes, excellent. Quotient function. Okay, Reshma. See, quotient function is this one. See, what happens is, suppose I have the function here, like I have x upon x plus 1. Okay. If my hx, not fh. Okay. If my hx is given by this. Okay. If my hx is given by this, then what is this? This is a division of two functions, that is quotient of function. So this is called as my first function, and this is called as the second function. Or you can call this as fx and this as gx. Okay. If you're comfortable with f and g, use f and g. But what I do is I always used to remember in words. So for those who find it difficult with f and g, I'm telling you this. So what does this mean is second function whole square, second function into derivative of first minus first function into derivative of second. This is also equal to gx. Okay. If you're comfortable with that, gx the whole square, then gx into d by dx of fx minus fx into d by dx of gx. Okay. Hope you've understood, Reshma. Abhinandan. Yes. Sri, you understood? Good. Yes, Reshma has also understood. Excellent. Then, what if it is an embedded function? This is called as embedded function. So the function is a function, the function is a function of another function. Okay. So actually, usually we have hx. We did this into gx. This was multiplication of two functions. See here, what you can see, f of x into g of x. But here it is not so. It is saying h x f of g of x. Okay. So let me put this in curly bracket. So that means it is the function is a function of another function. This is called as embedded function. So here what we do is we will write gx to be equal to z. Okay. we will write this inner gx, we will write it as z. So what will be my function? Hx is equal to f of, sorry, f of z. Okay. Hx is equal to f of z. Now, when I want to find the derivative, so this is equal to d by dx of hx. Okay. You can appreciate this. This and this has to be same. You will find derivative of the function with respect to x when the function itself is in terms of x, right? So what happens here? But this is d by dx of fz. Now this is x and this is z. So what do? I will write this as d by dz of fx. Okay. So this z and this z matches into, but I don't want a z because what I have a function hx, which is a function of f of gx. So in this is equal to dz upon dx. Okay. So this is what it is saying. Okay. Hx, which is equal to f of z, is equal to d by dx of hx. But here my f is in terms of z, so I will write this as, so you can see this dz and this dz. So d by dz of fz into dz upon dx. Yes, Anushka, you have understood? Excellent. So these are the basic rules that you should know about. Okay, so I'll just show there. It's there in your book. But I thought just by instead of just reading through it, I will explain it. So hx is equal to c of fx, so that my function is multiplied by a scalar, so a scalar multiple of a function. Then d by dx of hx is equal to c d by dx of fx. So the c comes out of the derivative. Second is, if my function hx is a addition or subtraction of two functions, then it will be d by dx of hx will be equal to d by dx of fx plus or minus d by dx of gx. When I have product of functions, then first function into derivative of second plus second function into derivative of first. If I have a quotient of a function, then d by dx of hx will be equal to, in the denominator, I will have second function whole square, numerator second function into derivative of first minus first function into derivative of second. Okay. And if I have an embedded function, hx is equal to f of gx, then it will be equal to d by dz of fz into dz upon dx, where I have gx, I have substituted as z. Okay. So what have we done? We have laid out all the foundation for solving the problems. Okay. So what we have all the different formulas for derivatives. We have the different rules for derivative. So now let us go into it. Some simple theory question you can even have. What does the derivative of a function represent? It represents the slope of the tangent of the line. Okay. So A will be the correct answer. Yes, Aisha has understood. Excellent. So suppose this is like, this is my y-axis. This is my x-axis. And let's see. I have such a type of curve. And I want to find the tangent here, slope. So I'll find the slope of the tangent. So what does this give me is, this is going to give me delta y, and this over here is going to give me delta x. Okay. So this is my tangent. I want to draw the tangent. Um, okay. I drew the tangent later so that I am able to write it well. Okay. So this tangent, the slope of the tangent will be given by delta y upon delta x. Okay. So slope will be equal to delta y upon delta x. Similarly, integration, what will integration give you? The integration of the function will give you the area under the curve. Okay. So if this is my x-axis, this is my y-axis, and this is my function. So if I want to find out this is given by my integration. Okay. Now let us go around solving sums. What I have done is, for each sum, I have written down the formula over there so that you will be able to understand how to do this. Okay. And so when you see the sum itself, you will be able to know, okay, this I have to solve using this method. Okay. So now my function is what? Function fx is equal to 3x square plus 5x minus 2. Okay. 3x square plus 5x minus 2. Now I want to find the derivative f dash x, or you can also write it as d by dx of fx. Okay. So what is the formula I'm using is x raised to n. Okay. Why I'm using this is I can see x square, I can see x, so this. Then what about this? It is what c into fx. Okay. So we know that d by dx of c into fx is c into d by dx of fx. Okay. Oh, Devendra has already answered. Very good. So this will become d by dx. First sum I will write each and every step so that you know how to do it. So if you have forgotten something, then also you'll remember. Now what will this be? You will be using the rule for addition. So this will be d by dx of 3x square plus d by dx of 5x minus d by dx of 2. Okay. Now this will become, I have to take the c outside. So this will be 3 d by dx of x square plus 5 d by dx of x minus d by dx of 2. Okay. Okay. Important derivative of a constant is always equal to 0. Okay. Remember that. So what will this be? 3 x square will be equal to 2x plus 5. The derivative of x will be equal to 1 and this will be 0. So this is equal to 6x plus 5. Okay. Yes, Prerna, Natasha, Reshma, excellent, excellent work. Now, this is an example I am particularly taking. Why? Because we may sometimes in a hurry write the wrong apply the wrong formula. This is a raised to x. Okay, so example is 3 raised to x. X raised to a means what? X cube. This is not equal to this. 3 raised to x and x raised to 3 are different. Plus a raised to 8 means 3 cube, suppose. So as you can see, they are not equal. So they are individually, it is different, and we have to always remember that we have to apply a different formula. What is the formula? 3 raised to x. So a raised to x, d by dx of a raised to x is a raised to x log a to the base e. Always remember, you may even get a question where they will, write down the log with a different base. So d by dx of a raised to x is a raised to x log a to the base e. And the other formula I'm using is d by dx of x raised to n is n x raised to n minus 1. Also remember d by dx of a constant is always equal to 0. Okay, these are the three formula I'm applying. So this is equal to d by dx of a raised to x plus d by dx of x raised to a plus d by dx of a raised to a. So whenever if you are in any doubt, instead of a, instead of n, write some number and see. Okay, see how it looks and then you'll remember which formula it is. Okay. This is equal to what? I'll use the first formula, a raised to x log a to the base e plus d by dx of x raised to a, x raised to n, x raised to n minus 1. So a x raised to a minus 1. And what will be the derivative of a raised to a? 3 raised to 3. It will, for example, it will be equal to 0 because it's a constant. Okay. X log a raised to a. Excellent. Yes, Reshma has got it correct. Devendra has got it correct. Yes, very good. Okay. So understood till here. Now let us take a longer sum. Now see what happens when I see this sum. I start running away from the sum. I feel, this is a very lengthy sum and I will not be able to get an answer. But no, just look at the sum. Just first, give yourself 2 to 3 seconds to just look at this and don't be afraid. Sometimes the smaller sums are more difficult than the larger ones. Okay. Now 1 by 3 x cube minus 5x square plus 6x minus 2 log x plus 3. Which are the formula I'm using? D by dx of x raised to n and d by dx of log x. This is equal to d by dx of 1 by 3 x cube minus d by dx of 5x square plus d by dx of 6x minus 2 d by dx of log x plus d by dx of 3. D by dx of a constant is always equal to 0. This will be equal to 1 by 3. Derivative of x raised to 3 will be 3x square minus 5. Derivative of x square will be equal to 2x. Derivative of 6x will be equal to plus 6. Derivative of log x will be equal to 1 upon x, so minus 2 upon x. And derivative of a constant will be equal to 0. Okay. So this 3 and this 3 will get cancelled. So what do I have? X square minus 10x plus 6 minus 2 upon x. Okay. So this will be the answer. Yes, Abhinandan, welcome back. Yes, Natasha. Devendra, not x cube, x square. Devendra, you've forgotten to find the derivative of x cube. X cube, you will use the formula d by dx of x raised to n. Okay. Just make those corrections. Anushka has got it correct. Reshma has got it correct. क्यों मल्टीप्लाई कर रहे हैं देवेंद्र आप? Don't multiply. You don't have to. अच्छा, okay, okay. Fine, fine. Devendra, your answer is also correct. But just look, okay, now Devendra has put forth a very important point. So sometimes you may have answer in this form, okay, okay. But as you can see, there is a x in the denominator. So you may sometimes in the option, because it will depend on what option you have. You will write upon x, okay. Then this will be equal to x cube minus 10x square plus 6x minus 2. Okay, so you may have answer in any of these form. Okay, but usually they will give it in this form. Okay, this you will write usually in the board exam, but here mostly you will get the answer in this form. They just want to see whether you are know the formula and you are able to apply it. Okay, yes, good point you put forth. Huh. Okay. Yeah. Now let us go to the next one. This is a multiplication of an exponential and a logarithmic function. Okay. So again, when you see such type of questions, don't get afraid. This is simply you have to use the derivative formula. You don't have to go, you are not supposed to draw a graph or anything, you just have to find the derivative. So what formula? You can see e raised to x into log x. Okay, so there is a multiplication. Okay, there is no sign here, implies there is a multiplication. Multiplication. Okay, so when you have this kind of thing, you have to see what is the formula for derivative of e raised to x. E raised to x, the simplest of all. Okay, very happy with this formula. I don't have to learn anything. And d by dx of log x, this is also a good formula. Okay. So I'm happy with both these formula. But what happens when I see the together, I feel, array, this is in log, this is in exponential. Don't worry. Okay. So now let us see. What is the rule? When your function is a multiplication of two functions, the derivative, what is the rule? First function into derivative of second plus second function into derivative of first. Okay. So my first function, which is equal to f of x, is equal to e raised to x. What is my second function, which is equal to gx, which is equal to log x. Okay. See, somewhere in your notebook, just write it there. Okay, so that day before the exam, you like, you get so worried. I don't know what step I had done. So somewhere you must write all the steps. You might not write them every time, but you must know it in your head. And while revising, you must have this one notebook where you're quickly seeing through your solved examples. And then once you have written like this, ff is equal to first function is equal to fx, second function is equal to gx, and then I will write the answer. So my d by dx of e raised to x log x is equal to first function into derivative of second function. This is a D. Let me write it properly. Okay. Plus second function into derivative of first function. Okay. So e raised to x d by dx of log x is 1 upon x plus log x into e raised to x. Okay. So this is equal to e raised to x upon x plus e raised to x log x. Okay. It's always better to write this e raised to x before so that you don't get confused. Okay. So you can also take it outside the bracket. So e raised to x is equal to 1 upon x plus log x. Okay. Let's see who have answered. Devendra, Sri, Natasha. Excellent. Yes, Reshma, very good. Very good. Okay. So let us go to the next sum. I have 2 raised to x raised to 5. So this is a classic example. This is like a raised to x and this is right x raised to n. Guys, my pen not writing properly today. Okay, so this is x raised to n. So as you can see, 2 raised to x into x raised to 5, I'm going to use the rule for when my function is a multiplication of two function fx into gx. Okay, so what is my first function? H is equal to f of x, which is equal to 2 raised to x. What is the derivative? Okay, what will be f dash x? This is equal to 2 raised to x log 2 to the base e. What is my second function? Second function is gx. Gx is equal to x raised to 5. What will be g dash x? G dash x will be equal to 5x raised to 4. Okay. So d by dx of 2 raised to x 5 x raised to 5 x raised to 5 is equal to first function into derivative of second, that is 5x raised to 4 plus second function into derivative of first function. Okay, so this will be the answer. So you could write this as 5 into 2 raised to x raised to 4 plus 2 raised to x raised to 5 log 2 to the base e. Okay, you can also take 2 raised to x common, 5x raised to 4 plus x raised to 5 log 2 to the base e. Okay, so it will depend on what type of answer is shown over there. Karthik, use black, okay? And Yana, you can even take x raised to 5, x raised to 4 outside, then you will be left with 5 plus x log 2 to the base e. Okay, this type of things also you can do, but it will depend on whether they are asking you. Mostly answer will be in this format, so this should be enough for you. Okay, now let us take a division sum. Yes, Sri, you could even have x raised to um, 5 or 4. It will be x raised to 4. See, it is x raised to 5, na? So, derivative of x raised to 5 will be 5x raised to 4. 5x raised to 4. Okay. Now, here, quotient of a function. Let me check. Yes, Karthik is there. Okay. So, this will be d by dx of x square upon e raised to x. What is my first function? First function is x square. What is my second function? Second function is e raised to x. So d by dx is denominator second function whole square. Then second function into derivative of first function. So d by dx of x square minus second function into d by dx of first function. So this is equal to e raised to x and x square will be equal to 2x minus x square. We know derivative of e raised to x is e raised to x upon e raised to x the whole square. Okay. Now, important. Sometimes answer is like this, then you won't have any issue, but because you can see there is e raised to x over here, so you can take e raised to x common. So you will have 2x minus x square upon e raised to x the whole square. So 1 e raised to x, 1 e raised to x gets cancelled. Oh, here it will get cancelled. So it will be equal to 2x minus x square upon e raised to x. Okay. And you can even have x outside the bracket. Okay. So sky is the limit. Yes. Okay, Shri. So you may have it the way Natasha, Shri, Devendra you have written, or you may even have that 1 e raised to x is cancelled. So sometimes if you see, you don't have to panic. If you see, you're quite similar. The options and your answer are quite similar, but there is a difference, a slight difference. Then you have to just see whether they have cancelled anything. Okay, or you have cancelled, but they have not cancelled. Okay, so either way, you should be able to understand. Yes, Anushka. Yes, very well, Anushka. So what you have to do is you have to keep practicing. So once you have practiced now, you will not be afraid. You will be very sure कि what answer I have got, that is correct. Okay. Let us move to the practical applications. Practical application is this derivatives differentiation is used to find the maxima and minima. Why would I want to find the minima? When I want to like see, I want to, if I'm a manufacturing unit, what would I like to reduce? I would like to reduce the cost, right? I would like to reduce the time within which a unit of goods is manufactured. Okay, because more the cost, less is the profit. Then, if I take less time to manufacture something, I will be able to produce more in the same amount of time. So that is why I must find the minima. When do I want to find the maxima? I would like to find the maxima when I want to maximize the profit, when I want to maximize the revenues. So in that time I will find the maxima. Okay. Now what is the rule that we have to use? A relative minima at the point x raised to a. So you will be able to solve the given function, and then you will be able to find a point A, and at that point A you will check whether there is a maxima or a minima. So at that point, if I find the first derivative and equated and that is equal to 0 at the point A, I there is a function, I find its derivative, and at the point I find the value of that derivative. If that is equal to 0, that is the first step, and then I find the second derivative. Means whatever derivative I have got, I find the derivative of that derivative. So that if it is greater than 0, if that is greater than 0, we say I have a minima. So you have a function. Okay, finds its derivative. Okay, then what is the third step? Find the value of the derivative at the point. If that is equal to 0, proceed further, find double derivative, find the value of the double derivative at point A. If it is greater than 0, you have a minima. Okay, this is the for minima. Okay, take the function, find its derivative, put the value, substitute the value A into. Yes. Now I want to reduce my cost. So in that I have the concept of marginal cost and average cost. What is marginal cost? What is the amount of cost that I will need to produce one unit of the product? Okay, one more unit of the product. So you already have done this in economics, and even I think in accounts somewhere you may have used it. And inter you have the whole subject of costing. There you'll be using it. So what is marginal cost? It is the total cost of producing. When the increase in cost is producing one more unit, is called as the marginal cost. So marginal cost. So whatever your cost function is given, this is cost. Okay. So divided by this total number of units, you will get the marginal cost. So dc by dx. And average cost is cx upon x. So average cost is simple. Okay. So to produce 10 pencils, if I've incurred 100 rupees, so 100 upon 10 will give me what? It will give me the average cost. But if I say, okay, in this batch, I manufactured 10 pencils. What if I want to manufacture 11 pencils? I just want one more pencil. How much more cost will I need? So that is given by the marginal cost. Yes, Abhinandan, in maths, you have done this. Okay. So we have, this is the cost function that the company has given us, asking us to find out the level of output at which the marginal cost is minimum, and the average cost is minimum. Okay. So we want that. Now what is X? X is the quantity. X is the quantity we want to find out, at which the cost will be minimum. So how do I do that? D by dx of cx. D by dx of cx d by dx of c and x is equal to d by dx of 100x minus 8x square plus x cube upon 3. Okay. I'll find the derivative. What is the derivative of 100x? It is 100 minus 8 into derivative of x square is 2x and plus 1 by 3. Derivative of x cube will be 3x square. So this is equal to 100 minus 16x and plus x square. Okay. Okay. Now, if I find this, what will I get? I get this. Now, equate to 0. Equate to 0. What will I get? X square minus 16x plus 100 is equal to 0. What are the factors of 100? 25 and uh, 25 and 4. 20, 20 into 5. Okay. So, what will I have here? Yes. Anybody giving me the answer here? Equate to 0 and tell me. Okay, so first I find d by dx of cx, and then I will be doing this. Yes, anybody with the answer? Okay. And then I will also find the second differential. So what is the second differential of this? It will be d by dx of x square minus 16x plus 100. Okay. So what will be the derivative? 2x minus 16. Okay. Plus 0. So this is equal to 2x minus 16. Okay. So that, what will I get here? I have got till here. Now I want to find, this is what I have done. What is the first term? Function. Then I found its first derivative. This is the function. I found the first derivative. Then what am I going to do? I'm going to find that and I'm going to put it equal to 0. Okay. So what do I have here? X square minus 16x plus 100. So what will be the factors here? What will be the factors? Are nobody is answering. What happened? Let me show it over here. This is x square minus 16x plus 100. Okay. So what do I have? Factors of 100 are 25 and 4. What else can I have? 20 into 5. What else? Anybody? No? Nobody's answering to. You're afraid? Okay. So let us see. Now let us see here. What is going to happen? I have x square minus 16x plus 100 equal to 0. You can always use b square minus plus or minus b plus minus b plus or minus under root of b square minus 4ac upon 2a. Okay, you could do that. Minus b plus or minus square root of b square minus 4ac upon twice a. Okay, so how much is b square? 256 minus 4ac minus 400. Okay, upon twice a. Okay, so that way also you could do it. Now let us see. I don't want a negative answer because I cannot have manufacturing to be less than this thing. To be a negative number, I can't do that. The minimum I can have is a 0. So if I put 0 here, what will happen? 0 minus 0 plus 100 is equal to 0. We don't want that. Now let us see. What will happen if I put x is equal to 8? X is equal to 8 is 8 square, 64 minus 16 into 8. Okay, so this is 64 minus, this is 8, 128 plus 100. Okay. Okay. So this is 100x, 2x and x cube. Yes. Yes. So what will I get? X is equal to 8. So you could do that and see. So you will get x is equal to 8. And at x is equal to 8, what will the value of this be? 2 into 8 minus 16. This is equal to 0. So when I put this equal to 0, I will get 8 here. Okay. So this is how you are supposed to do it. So what will you get here? You will have to see, put that equal to 0, find out the value and you will get the answer. Okay. So what I are getting here is that you are getting x is equal to 8. To find the relative minima at the point x is equal to 8, find f dash 0 and find f double dash a. If it is greater than 0, you will get the value as the point. So what is the minimum value? I must manufacture to have the minimum marginal cost, x is equal to 8. Okay. So here, once you do this, you will realize that how the answer is coming. So you will find the second differential. Here you will equate to 0 and you will get the answer. Okay. What will happen? With the average cost, now they want the average cost also. You have understood here? Okay. You've understood here 2x minus 16 is equal to 0. So you have 16 minus 16 is equal to 0. Now let us find average cost. Now average cost, average cost, is equal to cost function upon x. Okay. So what will I get here? What will I get here? This is equal to, this is my Cx. So Ax will be equal to 100 minus 8x plus x square upon 3. This is, I'm dividing by x. So this x and x will get answered. I will also write here 100x upon x minus 8x square upon x plus x cube upon 3x. Okay. So this will give me this. Now I want to find a dash x. A dash x, derivative of 100 is 0. Derivative of 8x is 8 plus derivative of x square is 2x upon 3. Okay. Then I find the double differentiation. Derivative of 0 is 0. Derivative of 8 is 0. And plus derivative of this is 2 by 3. Okay. So is my 2 by 3 greater than 0? Yes. Okay. So I have got this 2 by 3 to be greater than 0. Now I want to find how much is my value of a. So minus 8 plus 2x upon 3 is equal to 0. I have to equate a dash x equal to 0. So this is equal to minus 24 plus 2x upon 3 is equal to 0. So what it becomes 2x is because this 3, if I multiply by 0, it will be 0. So I have 2x is equal to 24 because minus 24 comes to this side. So 2x is equal to 24, which implies x is equal to 12. Okay. So x is equal to 12. So when will the average cost will be minimum when quantity manufactured is equal to 12. Okay. Understood this? Yes, 12. Yes, very good. Okay. 100x minus 8x square plus x cube upon 3 plus x cube upon 3. Okay. So this is my Cx. Okay. I'm just revising. C dash x is equal to 100 minus 16x plus x square. Okay. What will be my C double dash x? C double dash x. Okay. Derivative of this because I'm trying to find the marginal cost. This is equal to 0 minus 16 plus 2x. Okay. So this is equal to minus 16 plus 2x. So 2x is equal to 16, x is equal to 2. Okay. So x is equal to, 16 upon 2, which is equal to 8. Okay. So I found the first derivative, I found the second derivative, and equating to 0, I am getting x is equal to 8. Now I have to put it in C dash x. substituting in c dash x, which is equal to 100 minus 16x plus x square. So I will write 100 minus 16 into 8 plus 8 square. Okay. So this is 100 minus how much is this? 8, 9, 10, 11, 12. 128 plus 64. So this is equal to 164 minus 128, which is equal to 36, which is greater than 0. So what is the condition? That my function should be greater, the derivative of the function should be greater than 0, and my f double dash x, if it is, when I'm putting it to 0, I will get it the value of a. Okay. So for a point to be minimum at any point, we will have to find the derivative and find that the double derivative is greater than 0. Okay. So substitute the critical points. First find the critical point. Then C double dash of Q at the critical point. There is a local minima less than 0. It is a local maxima. And then you have to, if it is equal to 0, the test is inconclusive. Okay. So we've done this. Let us go to the parametric function. Okay. Now, what will happen for the parametric functions? When both the variables x and y are expressed in terms of a parameter or a third variable, the involved functions are called as a parametric function. So, if I have a variable x and I write it as f of t, I have another variable y and I write it as g of t, then they've taken h. Okay. Then f and g of t. So h of t, usually you pair f with g. So this is h of t. Then the derivative of. Okay. So then what will happen is, when I want to find dy by dx, but my y is in terms of t, I can't use it here. So what will I write? I will write dy by dt. Okay, for dy, I will write it as dy by dt into dt by dx. Okay, into dt by dx, and I will use this. Okay. So let us do the example, and then we'll take the break. Yeah, I know you get tired very fast, but there is such a lot to cover because I have only one session for derivative and integration. So let me, if dy by dx, see, x is given as is equal to a t cube, y is equal to a upon t cube, then dy by dt. Okay, dy by dt will be equal to a t raised to minus 3 d by dt of a t raised to minus 3, which is equal to how much? Minus 3 a upon t square. And how much will be dx by dt? This will be equal to 3a t square. So now when I want to find dy by dx, this is equal to dy by dt into dt by dx. Okay, so this is equal to dy by dt is how much? Minus 3a upon t square into dt by dx is t square upon minus 3a. Okay, so this t square, oh, t raised to 4, sorry, d by dt will be not minus 1, this is minus 3. Okay, this is minus 3, so this will become t raised to minus 4. Let me write it. Because this is t raised to minus 3, because This is t raised to minus 3. So t raised to minus 3 derivative will be equal to t raised to minus 4. Okay. d by dx, d by dt of t raised to minus 3 will be equal to t raised to minus 4. So this will be t raised to 4. Okay. Because I have taken in the denominator, it becomes t raised to 4 in the denominator. Or if you write it in the numerator, you will have to write it as minus n. So this is giving me what? This 3a get cancelled. The minus sign I have over here, dy by dt, and here it is plus. So this is equal to, with a minus sign, t square and t raised to 4 dt by dx. So now this is what dx by dt is 3a t square. So how much will be dy by dt by dx? How much will be dt by dx? Is equal to 1 upon 3a t square. Okay, it will be 1 upon 3a t square. So this is equal to 1 upon 3a t square. So this 3a gets cancelled, 1 upon t square, and this is 1 upon t raised to 4. This is equal to minus sign. This minus sign is there. 1 upon t raised to 6, because t raised to 4 into t raised to 2, t raised to 4 into t raised to 2 is equal to t raised to 6. Okay. So dt by dx is 1 upon 3a t square, and this is the answer. Okay. Understood? Just quickly put in the chat box whether or not you've understood. Okay.
Students, this example is very important.
So let us quickly do the logarithmic one. Yes. Yes, Abhinandan, Devendra, Anushka, you've understood? Yeah, very good. Now what happens in logarithmic function is the process of finding out derivative by taking log in the first instance is called as the logarithmic function. So you have a function, you take the log, and then you do the further process. Okay. So differentiating x raised to x. So x raised to x. So my y is equal to x raised to x. So when I take logs on both sides, this is going to be log y. It is equal to log of x raised to x. What is the thing I'm going to use? Log of a raised to m is equal to m log a. Okay, what am I using? Log of a raised to m is m log a, which is equal to x log x. So how much is my log y? Log y is x log x. As you can see here, what is happening here? It is the multiplication of two functions x and log x. Okay. So which formula I'm going to use? I'm going to use hx is equal to fx into gx. Okay. I'm going to use this formula, finding the derivative when it is. So how much is h dash x? Is equal to first function into derivative of second function plus second function into derivative of first function. Okay. So first function into derivative of second plus second function into derivative of first. So when I solve this, how much do I get? So log y, we know what is the derivative of log y? D by dx of log y log x is equal to 1 upon x. So d by dx of log y will be equal to 1 upon y dy by dx. And derivative, this will be log x plus x upon x. So first function into derivative of second. What is the second function? And second function into derivative of first. So log x plus x upon x. If you want, I will write it down here. This is equal to 1 upon y dy by dx. Okay, the derivative of log y is 1 upon y dy by dx. And what will the derivative this be? X, first function into derivative of second, that is 1 upon x, plus second function log x into derivative of first function is 1. So this is 1 plus log x. Okay, so this is the derivative here. But what do I have on the right hand side? I have 1 upon y dy by dx is equal to 1 plus log x. But I don't want this. I just want dy by dx. So I cross multiply. So dy by dx is equal to y into 1 plus log x. And what is y? Y is nothing but what is the function that they have given? Y is equal to x raised to x. So resubstituting, I know y is equal to x raised to x. Okay. So I'm going to use this. So this is equal to x raised to x 1 plus log x. X raised to x 1 plus log x. So this is how you are going to solve it. The second one, yes, exercise 8A, seventh question. Parul. Okay. Let me see what the question is. Okay. Just let me see. Eight A, seventh question. Xy is equal to 1, then y square plus dy by dx is equal to. If xy is equal to 1, then how much will this be? Just let us see. She's asking if xy is equal to 1, then what is the? Then y square plus dy by dx is equal to, isn't it? This is the question. Seventh question. And y square plus dy by dx is equal to how much? Okay. On both sides. What will I use? I will use hx is equal to fx into gx. So what will be h dash x? It will be equal to first function into derivative of second function plus second function into derivative of first function. Okay. So I have xy is equal to 1. So taking derivative of both sides, first function into derivative of second function plus second function into derivative of first function is equal to derivative of 1. Okay. What is dy by dx as it is? So this is x dy by dx plus y. Derivative of x is 1 and this is equal to 0. Okay. So I have x dy by dx plus y is equal to 0. What do they want? Y square plus dy by dx. Okay. So this is equal to how much? They want the value of y square. So if I multiply by y, okay, multiply by y. So I will have xy dy by dx, okay, plus y square. Because why did I multiply by y? This is the important step because I want y square. Here I have only y. So I'm multiplying by y. So xy dy by dx plus y square is equal to 0 because I multiply 0 by any number I'm going to get 0 only. Now I know that xy is equal to 1. So instead of xy over here I'm going to write 1. So 1. So it will be dy by dx plus y square. It will be equal to 0. Okay. Because xy is equal to 1. Okay, Parul? Got your answer? Okay. Now let us go to integration. Yes, okay. Sir, would you like to talk about integration, sir? Okay. So integration, when we are trying to accumulate, we are talking about integration, okay? So integration is a fundamental concept in calculus that involves in finding accumulation of quantities and usually area under the curve. Differentiation is rate of change and integration is talking about accumulation. Okay. So integration is applied in finance for calculating compound interest, growth of savings or investments. And you also use in biology for the same, for population. Sneha, are you still there? I think Sneha is not there now. Okay, so finding the pollution level. Okay, you know the pollution over at different times of the day, and then you will extrapolate it to find the mm, uh, total pollution exposure. Okay, so there also you can use it. Okay, integration is reverse of differentiation. We know this. These are the formula that we are going to use. So integral of a raised to x. Okay, e raised to x dx is equal to e raised to ax upon a plus c. Okay, so important is this plus c because we know that the derivative of a constant is 0. So when I'm doing the reverse, I do not know whether that original equation had a constant or not. And so that is why I will write plus c. How do I find the value of plus c? Usually you find it when we are dealing with the definite integrals. Okay, so if any information about definite integrals is given, in that case, I am able to find out. Okay, so these are the different formulae that I must know. E raised to ax is equal to e raised to x upon a. Then d by dx of 1 upon x is equal to log x because I know derivative of log x is 1 upon x. So integral of 1 upon x is log x. Then a raised to x dx is equal to a raised to x upon log a plus c. Okay. So here you will get the answer like this. So as we do the sums, you will have. Okay. And these are important for theory also. D by dx of upon that is 1 upon x square minus a square. Okay. So like suppose I have 1 upon x square minus 4. So in that case, I will use this formula. because here what will I write? This is nothing but 1 upon x square minus 2 square. Okay. Now if I have same thing applies for here, suppose I have 1 upon 9 minus x square. This is equal to 1 upon 3 square minus x square. Okay, these are the formula you can get for theory also. Okay, all these formula are there in they are there in the textbook. We will usually use the normal ones where you will simply apply a formula and get the answer. Okay, so let us go to this. Now integral of square root of x dx. Now I know that square root of x is written as x raised to half by my indices sum. So integral of x raised to half dx. What is the formula? Integral of x raised to n is x raised to n plus 1 upon n plus 1. So this is equal to x raised to half plus 1 upon half plus 1. So this is equal to 2 by 3 x raised to 3 by 2 plus c. Okay. So integral of this will be equal to plus c. Okay. What will happen if the x is in the denominator? Okay. What will happen if the x is in the denominator? Now I know that 1 upon a raised to m is equal to a raised to minus m. So 1 upon square root of x can be written as 1 upon x raised to half, which is equal to x raised to minus half. So what will I do? I will have integral of 1 upon square root of x dx is equal to integral of x raised to minus half dx. So this is equal to x raised to minus half plus 1 upon half plus 1. Okay, minus half plus 1. This is plus c. How much will this be equal to? Because this will now flip. So I will have 2 square root of x plus c. Because minus half, remember minus half plus 1 is equal to plus half. Plus half is the square root of square root sign. Okay. I hope everybody is following this. Now let us go to the next sum where I'm using the formula that we discussed just now. Integral of e raised to ax dx is equal to e raised to ax upon a plus c. So what is my a here? A is minus 3 here. So integral of e raised to minus 3x dx, there is this minus sign, is equal to e raised to minus 3x upon minus 3 plus c, which is equal to minus 1 by 3 e raised to minus 3x plus c. Okay. 3 raised to integral of 3 raised to x dx is integral of a raised to x dx is a raised to x upon log a plus c. So how much is a? A is equal to 3. So here integral of 3 raised to x dx will be equal to 3 raised to x upon log of 3 to the base e plus c. Next is integral of x root a. Now this is not the multiplication. This is simply, I have two functions in x. So x and square root of x. Now I have a raised to m into a raised to n. The formula for indices, it is equal to a raised to m plus n. Remember here a and a are common. Okay. So here also x is there. So this is equal to x raised to 1 into x raised to half. Okay. This x means it is x raised to 1. So this is equal to 1 plus half. X is equal to 1 plus half, which is equal to x raised to 3 by 2. Okay. Now I have this. So I will not use the integration by parts formula here. Okay. you don't need to use it. It is this simple one. So integral of x root x dx will be equal to x raised to 3 by 2 plus 1 upon 3 by 2 plus 1 plus c. So this is giving me how much? 3 by 2 plus 1 is 5 by 2. So this will be 2 by 5 because this denominator, this is going to flip. Okay. This is 5 by 2. It will become 2 by 5 and x raised to 5 by 2 plus c. Okay. Yes, very good, Natasha. And don't forget this thing. Now this you can use the formula a plus b whole square. Algebraic formula is a square plus twice ab plus b square. Okay. So what will I get? I will get x plus 1 by x whole square is equal to x square plus 2 into x into 1 upon x plus b square will be 1 upon x the whole square. This is equal to x square. This x will get cancelled with this. So plus 2 and 1 upon x square. Yes, Abhinandan, I'm going to explain integration by part. Okay, don't worry. So what will be the derivative? D by dx of x square plus 2 plus 1 upon x square. 1 upon x square can be written as x raised to minus 2. Okay. It can be written as x raised to minus 2. Okay, that becomes easier for us. So derivative of, not derivative, we are finding the integration, right? So integral of this dx is equal to, what is the integral of x raised to 2? It will be x raised to 3 upon 3. Derivative of 2 will be 2x. And this will be plus x raised to minus 1 upon minus 1 plus c. Okay, so this will be the answer. So this is equal to x cube upon 3 plus 2x and x raised to minus 1 will be 1 upon x. So minus 1 upon x plus c. So you may have it in either form. Okay, so what is the rule that you must follow while solving integration by parts is it is known as the Eilert rule. See, this is not there in your syllabus. So you may forget about the inverse trigonometric, and you may forget about the trigonometric. Okay, but when you are searching for something, you will get this. So Eilert. So what you will do is first function will be this is the order L A E. So logarithmic, then algebraic, and then exponential. Okay, so this is the rule that you must do. Let me see whether I have taken. This also you can do on your own. This also you can do on your own. Substitution, partial fraction. Yes, integration by parts. Okay. So what does integration by part mean? Is this. I will take the, if time permits, I will also take substitution method. Don't worry. Now you have to remember this formula. Okay. Eilert, the rule, sorry, not formula. Of which we don't have the I and you don't have the T. Okay. So L, A, E. Logarithmic, algebraic, exponential. Now what does integration by part in integration mean? Is that if I have two functions, if I have a function which is a multiplication of two functions, then the integration of that function will be given by first function into integration of second function minus integration of derivative of the first function into integration of the second function. Yes. So integral uv dx is equal to u integral of v dx minus integral of derivative of u minus integral of v dx. So you can write it as this. If I call it as the first function and this I called as the second function, then integral of uv will be equal to first function into integral of second function minus integral of, okay, minus integral of derivative of first function into integral of second function, okay, plus c. Obviously plus c will always be there. So integral of uv is u into integration of v minus integral of derivative of u into integral of v. Okay, so this is the formula that we are going to use. So let us try it on one sum. So x e raised to x l a e. So what will be my first function? Logarithmic. Do I have a log function? No. So I have an algebraic and an exponential. So first function must be algebraic, second must be exponential. So this will be my first function and this will be my second function. Okay, first function and second function. So what does uv say? U into integral of v minus v integral of derivative of u into integral of v dx. Okay, so this is equal to first function. First function is how much? X into integral of second function. So integral of e raised to x. So let us, instead of directly writing, I usually do this way. Okay. So what do I do? First function derivative. What is the first function here? First function is x. What will be its derivative? Its derivative will be 1. Second function is how much? E raised to x. So what will be the integral of second function? It will be equal to e raised to x. Okay. Now, first function into integral of second function is e raised to x minus integral of derivative of first function is 1 into integral of second function is e raised to x plus c. Now again here, in always remember integration by parts, you will integrate at least 2 times. So x e raised to x minus integral of e raised to x dx is again e raised to x plus c. So this will be your answer. Abhinandan, I hope you've understood. Okay. Before we go to the partial. Okay. This then, yes. Very good. Now there is also called as method of substitution. So in method of substitution, what you do is, because see, if had it been a plus b whole square, I could have expanded the whole thing and I could have done that. And I could have found the integration or differentiation. But in this case, what happens is when I have this kind of things like 2x plus 3 raised to 7, then what happens is it becomes very difficult for me to use anything over here. So what I do is, in this case, I use what is called as method of substitution. So in method of substitution, whatever the big function is, I substitute it as something and then I will try to find the answer. Okay. So, and we also know parametric, so we could combine those two things. So let 2x plus 3 be equal to, what do you want to use? Which alphabet? Let's say Z. Okay, let 2x plus 3 be equal to Z. That is the first step. Differentiating on both sides. What will I get? 2 dx plus 0 is equal to dz. Okay, 2 dx where on both sides with x. Okay, with. Okay. So differentiate. This is the most important thing. So here what will I have? Dx is equal to dz upon 2. See, always remember in such sums, you will have to first find the substitution for this and then everything will be taking place. So what I have, integral of 2x plus 3 raised to 7 dx. Instead of 2x plus 3, what will I write? Z. So this is equal to integral of z raised to 7. Instead of 2x plus 3, I am writing z. And instead of dx, what will I write? dz upon 2. Okay. Don't forget. Don't forget. Otherwise, I substitute for the function and I forget about the dx. That should not happen. So, this is dz. Now, what will this be? This I can rewrite as 1 upon 2 integral z raised to 7 dz. Which formula I am going to use? Integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Okay. So this is equal to 1 upon 2 z raised to 8 upon 8 plus c. Now what is this? 2 into 8 is 16. 1 upon 16. Z is how much? 2x plus 3. 2x plus 3 raised to 8 plus c will be the answer. Okay. Then I have to talk about the partial fraction method. Now, what happens in partial fraction is that when I am doing fx upon gx, so this is actually a type of fx upon gx, but when I'm using fx upon gx, it is easier when the numerator, the power of x in the numerator is less than the denominator. Fine. Here I can do that. But when I try to do this in the denominator, it becomes very sticky, when I'm trying to use the formula. So what we do is instead of writing like this, we will write it in this form. Okay. So I will write 3x plus 2 upon x minus 2 into x minus 3 to be equal to a upon x minus 2 plus b upon x minus 3. Okay, whatever the denominator factors are there, I am going to separate them. Now I will cross multiply. So this is equal to a into x minus 3 plus b into x minus 2 upon x minus 2 and x minus 3. Okay. Now the denominators are same. Denominators are same. So equating numerators, what do I get? 3x plus 2 is equal to a x minus 3 plus b x minus 2. Okay, I will expand this. This becomes ax and this becomes bx. So a plus b into x minus 3a minus 2b. Okay, so this implies a plus b is equal to 3 and minus 3a minus 2b is equal to 2. And then you solve this using the simultaneous equation and you are going to get x, the values of x. Okay. Values of a and b. Okay. Not x. Values of a and b. Okay. And then because these are simple simultaneous equation that you need to solve. Okay. Mm, done integration by parts also. Okay, this is one sum I want to take with you. That is the log x sum, because what happens here is LAE There is no direct formula for log x. There is no direct formula for log x. And so what we need to do is, there is this typical way you can even learn the answer. But in this case, I think the answer is none of these. So you could simply do this and you will get the answer. I'll just show you the method to do it. Now this is integral of log x dx. Okay. Now in this case, you will write this as integral of log x into x raised to 0 dx. Okay. LAA. So log is coming first and then algebraic, and there is no exponential here. So when I use this, this is log x and x raised to 0 is 1 dx. Okay. That is why I introduced this. So I will use integral by parts. So first function into integral of second function. So log x into integral of 1 dx minus integral of, what is the derivative of log x? It is 1 upon x into integral of 1 dx, the whole thing dx. Okay. So integral of log x 1 dx is x. So this is equal to x log x. Now what will this be? Integral of 1 dx. I will do the integration first. That is x. So minus integral of 1 upon x into x dx. So this x will get cancelled and it is integral of 1 dx. Remember, integral of 1 dx is equal to x. So this is equal to x log x plus c. And this will be minus x plus c. Okay. So this will give you the whole answer. Then we have the applications. I hope everybody is able to understand. Hmm? Just put it in the chat box whether or not you are understanding and enjoying the session. Yes, Abhinandan, Natasha, very good. Others, I hope you are understanding and enjoying at the same time. Shri is also Kirtana, very good, very, very good. Reshma, yeah, good that you are enjoying. And one of the last things that I have to take is find the equation of the curve when the slope is given. See, when you are saying slope is given, what does it imply? Whether it will be derivative that is given or integration? Can anybody tell me? When they're saying, yes, Anushka is saying you understood. Yeah, Prerna also loves it. Thank you. Devendra also. Okay, quickly put in the chat box. When I'm saying find the equation of the curve when slope is given. Slope, whether it is derivative or integration. Remember the MCQ we had done in the first 5 minutes. What does derivative give you? And what does integration give you? Integration gives you area under the curve. And yes, very correct, Reshma. It is giving you the derivative. Okay. So what is given to you? Derivative. Where slope at xy. So derivative is given. So slope at xy means what? dy by dx is given. Okay, dy by dx is given. So they have given you dy by dx to be equal to 9x. Okay, find the equation of the curve where slope is 9x, which passes through the origin. Okay, this is also extremely important. Passes through the origin means what? 0, 0. X is 0, y is 0. Okay, so whatever the slope is, it is passing through the origin also. So now this I will write it as dy is equal to 9x dx. Integrating on both sides, what do you get? Integral of dy is equal to integral of 9x dx plus c. Okay. Integral of 1 dx, dy means 1. So integral of 1 dy will be equal to y. Integral of 9x dx will be equal to 9x square upon 2 plus c. Now, how do I find the c? I find the c, to find c, use 0, 0. Why I am using 0, 0? Because they have given me that the curve is passing through origin. मैं अपने मन से नहीं कर रही हूँ, because they've already given me that. So 0 is equal to 9 into 0 square upon 2 plus c. So how much is c? C will be 0, 0 and is equal to 0, so c is 0. So what is my curve? Curve is 9x square upon 2. This is my curve. Okay. So this is what they've asked. Now find the equation of the curve. So what is the equation of the curve? Y is equal to 9x square. See, I have put it in this. So you can see when I change the values of x and I find, and when I plot them, I can see yes, it is passing through the origin. So this is the beauty of derivative and integration. Okay. These are some of the rules that you must know. Um, okay. This is something that can be asked. E raised to x is into fx plus f dash x is equal to e raised to x fx plus c. Okay, this is simply by using the integration by parts. So there is no need to like mug it up. Here, this is important. That's you can easily use it. F dash x upon fx is equal to log x. So if I have integral of if the function is there and then the derivative is the function is available in the numerator, then it is equal to log x, log of fx plus c. Again, this whole thing you can do it actually also and you can get the same answers. Then here they may ask you what is the symmetric property of definite integral. Symmetric property of definite integral is integer of a to b of fx is equal to minus integral of fx from b to a. So if you just change the direction, okay, from going from a to b, and then if I'm going from b to a, there is only a change in the sign. Okay. And here you could, like, if I have A to B, then I can go from A to C and then C to B. So if I want to find the integral between these 2 points of the curve, suppose my curve is like this, then I can even have here this point C. So first I will find the integral up to here and then I can find the integral up to here. So if suppose there is a some point of inflection, then you could do that. This is also important. F of x dx is f of a minus x. So this also you can use. This is usually used, why? So that the function that is given, you can simplify the function. So there you could use it. Okay. And if your function is going from minus a to plus a, okay. So if it is minus a to plus a, what does it show on the number line is here. This is your minus a. This is my 0, 0. And this is my plus a. So minus a to 0 and 0 to plus a. So you can see they are as good as equal parts. So this can be written as, this is written as 2 integral 0 to a fx. Okay. Now let us solve this. Integral of 0 to 2 x raised to 5 is equal to integral 0 to 2 x raised to 5 dx. I know that integral of x raised to n dx is equal to n x raised to n plus 1 upon n plus 1 plus c. So this is equal to x raised to 6 upon 6 and it is written as 0 to 2. Okay. So I will substitute for x, I will substitute 2. So 2 raised to 6 upon 6 minus 0 raised to 6 upon 6. So 2 raised to 6 is 64. 64 upon 6, 0 upon 6 is 0. So this is equal to how much? 32 upon 3. Okay. And same thing you could do with the other sums. Okay. This is the last sum I will take. See, here this is important. Why? Because yeah, we have written it here. We use the method of adding integrals so that on the left hand side we get 2i. Okay. So the question here was find the integral 0 to 2 of x square plus 2 minus x the whole square. Now let me put this as equal to I. I is equal to x square plus 2 minus x. Now what I do is this using the property. I am using this property. Fx is equal to f of a minus x. So you can write fx as f of a minus x. So what do I do? This can be written as instead of x square, I will write it as 2 minus x the whole square. So the I is also equal to I is equal to this, the given question, and I is also equal to 2 minus x whole square. Instead of x, I am writing 2 minus x the whole square. And again 2 minus x I am writing as x square. Now this is 2i, not 21. Okay. I am adding these two, this I and this I. So I am writing the first, I am writing the second, and I add them up. Now you can see the denominator is same. So I will write x square plus 2 minus x the whole square, and this will be in the numerator x square plus 2 minus x the whole square. Okay, x square. Now you can see the numerator and denominator is cancelling. They are giving you answer as 1. So this is equal to integral of 1 dx. 1 dx, integral of 1 dx is x. So x going from 0 to 2. So 2 minus 0, which is equal to 2. So but always remember, okay, this is very, very important that you are getting 2i. The answer is what you are getting is 2i. 2i is equal to 2. And so I is equal to 2 upon 2, which is equal to 1. Otherwise, you'll feel that you've got the answer and you'll tick the incorrect answer. Why? Because you must remember on the left hand side, you have 2i. This is answer is for 2i. So 2i is equal to 2, I is equal to 1. Yes. Okay. Ashok ji? Yes. I have finished. Thank you all for your wonderful hearing. You've been very patient and done very well. Thank you so much. Yes. Yes, Abhinandan, you are always welcome for a great explanation from me. And all the best, study. Yes, Reshma, what do you need help with? Unmute कर दीजिए.
हेलो।
हेलो, हाँ बोलो.
मैम, मेरा रेगुलर में जॉब चलती है, तो मेरे से सारे लेक्चर अटेंड नहीं हो पाते हैं। और जो सैटरडे संडे के होते हैं उसी में मैं ज़्यादातर कर सकती हूँ। अगर रिकॉर्डेड लेक्चर में मेरे को कोई क्वेरी हुई, तो मेरे को अगर उसको सॉल्व करवाना हो तो कैसे उसका सॉल्यूशन हो सकता है?
वो आप ईमेल पे भेज दीजिए इंस्टीट्यूट को, तो आंसर हो जाता है वहां पे. काफी सारी
ओके।
फैकल्टीज हैं, तो वहां पे आपको आंसर मिल जाएगा किसी भी सब्जेक्ट के लिए.
ओके, थैंक यू मैम।
Okay. Anybody else has any question? Yeah, I think we are done. Happy studies. I think we are going to have rains in a week's time, and so all the heat will also be a little bearable. Till that time, have a great studies. Okay. Thank you. Yes. Thank you, everybody. Leave कर दें हम? Yes, over.